So this is a typical sine curve, but sometimes what you're going to find, there are numbers instead of degrees, but we're going to do word problems that have this problem. So the definition of the period, let's not do that first. Let's do the amplitude. So the original sine function, you might have noticed, goes between 1 and -1. So that's a characteristic of the original sine function. I don't know why this is so slow. Goes from 1 to -1. Now this particular sine function, we know it's a sine function because it's going 0, it's reaching a maximum, going back to 0, -1, and 0. That's how we know it's a sine function. But this particular function has a maximum at +2 and has a minimum of -2. So without analyzing it too much, I know right away that this function has the equation y is equal to 2 sine x. If we talk about transformations, your a term represents a certain transformation. If your a is greater than 1, what kind of transformation is that? Does anyone know? Keith? Vertical stretch. A vertical stretch by 2. So we could say that if we were analyzing transformations, but the main, this a term has a new role now, and it's called, and with sine functions, the role that it plays is the amplitude. And the amplitude is basically the magnitude or height of the oscillation wave of a sinusoidal function. It's also defined as the difference between the maximum and minimum values. So you should write that down. So now there are some formulas attached to the amplitude. If you're given the graph right away, like in this question, I know that I would write the amplitude is equal to 2. However, in your unit guide, sometimes you're given the graph or you're asked to draw a function first, and we're going to do a word problem that's similar to that, and you have to figure the amplitude on your own. That's why I wrote the definition, the difference between the maximum and minimum values, because if you get a situation like that, you have to actually use this formula in order to find the amplitude. So your amplitude is basically your maximum value minus your minimum value Something else you have to figure out when you're doing your equation is something called your period. So the definition of the period is how long it takes to complete one full cycle. For this particular graph, it's also a sine function. The period would not be in terms of radians because I can see that I have numbers along my x-axis. So the period is actually to complete one full cycle. I know I don't have a vertical stretch because it's moving from +1 to -1. But to complete one full cycle, that's a little after 6, probably 7. So over here my period is 7. But there is also a formula to figure out your period. So we're going to talk about, let me just show you with the transformation equation. So this is the transformation equation that we've been using all this time. Q x minus h plus k. In terms of the transformation equation, I already know my A term represents my amplitude. Let's try light blue. So now Q term represents your period. Your Q term represents the period. And to find the period, when you're given an equation, you basically take, the formula for that is 2 pi divided by whatever your Q term is. Now in your textbook, they actually interchange these. So let's go by what your textbook says. Instead of Q, your textbook is representing your horizontal stretch and compressions by the letter K, and we can use V for your vertical stretch. So the formula for period is 2 pi over K, 2 pi over K. That's something that's introduced in your textbook, and I just don't want you to confuse your formulas. So your K term represents your horizontal compressions and stretches. It's also the way you calculate your period. So I'm going to put 2 equations on the board so you have examples of what I'm talking about. So equation A. If you have your equation, y is equal to 2 sine 1/2 x. So if we ignore the sign, just based on your knowledge of transformations, what kind of transformations are applied on this graph? I know that this represents a transformation, this 2 represents a transformation, and the 1/2 represents a transformation. Can someone tell me what transformations have been applied? Does anyone know? Chris? So we have a vertical stretch by 2 and a horizontal stretch by 2. I know that the amplitude is 2 right away. The way you find your period, though, from this equation, I know that my K term is equal to 1/2. The formula for period is equal to 2 pi. Sometimes when you're dealing with numbers, remember 2 pi is the same as 360 degrees. So sometimes we use the number 360 over my K value of 1/2. That's the same as 2 pi divided by 2 is the same as 2 pi multiplied by 2 over 1. So my period in this case is 4 pi. 4 pi is basically 4 times 180 degrees, or 360 degrees plus 360 degrees, 720 degrees. What this means is that the graph has been stretched so far, like horizontally, that to complete one full cycle, it takes, instead of taking 360 degrees, it now takes 720 degrees to complete one full cycle because it's been stretched. So the transformations make sense with the period. Let's do another example. So if I have y is equal to negative 1/3 cos 4x. Now the negative 1/3 tells me that the graph has been vertically compressed like this. So the maximum and minimum is going to be less than 1 and negative 1. It's been vertically compressed by 1/3, but it has also been horizontally compressed. So instead of having, remember your original function has a period that goes from 0 to 2 pi. This period we expect, because horizontal compressed, it's getting squishy, and so the period should be less than 2 pi. Let's check if that's the case. My formula is period is equal to 2 pi divided by k. I just want to highlight my k term. Do never confuse your A term and your K term. My K term is the 4. So period is equal to 2 pi over 4. We can reduce this. 2 goes into 4 twice. So my period is pi over 2. Pi over 2 is the same as 90 degrees. So instead of having one cycle take place over the course of 360 degrees, it's been all squished, so it all takes place in 90 degrees. What that's going to look like, if I just go up on this graph, keep going up. So for example, if this was 2 pi, if this was 2 pi right here, and 90 degrees, because this would be pi, so 90 degrees would take place like at pi over 2. Basically, what would happen is that whole cycle, the graph going up, down, and back up, would happen in 90 degrees instead of 2 pi. It could be really compressed like that.